Kinetic energy is the energy an object possesses due to its motion, determined by its mass and velocity. Let's look at some real-life situations and see how things moving around demonstrate kinetic energy. Bowling ball. The bowling ball in motion, rolling towards the pin, possesses kinetic energy, representing its energy of motion. Accelerating car. The car speeding down the road possesses kinetic energy, a result of its motion and velocity. Airplane. The airplane soaring through the air carries kinetic energy, representing its energy associated with its flying motion. Meteor. The meteor floating in space possesses kinetic energy, representing its energy derived from its motion through the vast expanse of space. Rocket. The rocket launched from the Earth exhibits kinetic energy, representing its energy resulting from its propulsion and movement. Large truck. The large truck running on the highway possesses kinetic energy, representing its energy due to its motion. Avalanche. The avalanche cascading down a mountain possesses kinetic energy, representing its energy as it moves swiftly and forcefully. Bullet. The bullet propelled from a gun possesses kinetic energy, representing its energy as it travels through the air. Cricket ball. The cricket ball released by a bowler carries kinetic energy, representing its energy associated with its throwing motion. Insect. An airborne insect demonstrates kinetic energy as it moves through the air, representing its energy due to its flight. Moving bike. The bike racing on the highway exhibits kinetic energy, indicating its energy derived from its motion on the road. Playing cards. The cards falling from a tower of playing cards hold kinetic energy, representing their energy as they descend towards the floor. Roller coaster. The wagon of a moving roller coaster possesses kinetic energy, representing its energy resulting from its motion along the tracks. Athlete. The athlete sprinting in a race carries kinetic energy, indicating their energy linked to their running motion. Bird. The bird gliding through the sky showcases kinetic energy, representing its energy resulting from its flight through the air. River water. The flowing water in the river possesses kinetic energy, representing the energy associated with its downstream motion. Clouds. The clouds moving in the sky exhibit kinetic energy, indicating their energy resulting from their motion through the atmosphere. Skateboarding. The person riding a skateboard possesses kinetic energy, reflecting their energy resulting from their movement on the skateboard. Baseball. The baseball thrown by a pitcher holds kinetic energy, representing its energy associated with its throwing motion towards the catcher. Satellite. The satellites orbiting the Earth possess kinetic energy, representing their energy arising from their motion along their orbital paths. All right, those were the examples of kinetic energy. Now let's explore the equation and work through some related practice problems. The kinetic energy equation is typically expressed as KE is equal to half times mv squared, where KE represents kinetic energy, m is mass, and v is velocity. This equation facilitates the calculation of the kinetic energy of an object using its mass and velocity. Let's solve some practice problems to understand and apply the kinetic energy equation. Calculate the kinetic energy of a 2.5 kilograms basketball moving at a velocity of 8 meters per second. Write down the provided data, input the values into the formula, and calculate the kinetic energy as needed. We have to find the kinetic energy, so KE equals question mark. The mass of the basketball is given as m is equal to 2.5 kilograms, and it is moving with a velocity, v equals 8 meters per second. Insert these values into the equation Ke equals half times mv square. Therefore, the calculation becomes Ke is equal to half multiplied by 2.5 multiplied by 8 square, which gives the value as Ke equals 80 joule. Therefore, the kinetic energy of the basketball is 80 joule. Let's take one more practice problem. Determine the kinetic energy of a 600-gram remote-controlled car traveling at a velocity of 5 meters per second. Note the given information, plug in the values into the formula, and find the kinetic energy as requested. Find the kinetic energy, so write Ke is equal to question mark. The mass of a remote-controlled car is given as m equals 600 gram, which equals 0.6 kilograms. And it is moving with a velocity, v is equal to 5 meters per second. Simply place the given values into the equation Ke is equal to half times mv square. So the calculation becomes Ke is equal to half multiplied by 0.6 multiplied by 5 square. This becomes Ke equals half multiplied by 15. And we get the value of Ke as 7.5 joule. Hence, the kinetic energy of the remote-controlled car is 7.5 joule. So, that wraps up kinetic energy. If you found this brief explanation helpful, please like the video, share it with your friends, and subscribe to the channel.